Have you ever wondered how the creamy butter on your toast is mass-produced with precision and care? Let's have a look at the intriguing process of creating butter in a modern facility. The journey begins with sourcing fresh, high-quality milk from trusted dairy farms. Dairy farms that supply milk for butter production frequently follow stringent guidelines to ensure the health and welfare of their cows. The milk is collected twice a day to ensure freshness and quickly chilled to retain quality. Tanker trucks equipped with temperature control systems convey the milk to the factory, where it is thoroughly inspected upon arrival. The milk is evaluated for lipid content, bacterial count, and overall purity. Only milk that satisfies these stringent requirements advances to the next stage. Once authorized, the milk is poured into high-capacity separators that spin at more than 6,000 revolutions per minute. This centrifugal force separates the cream and skim milk, sending the heavier skim milk to one exit and the lighter, fat-rich cream to another. Factories frequently use modern automation to monitor and optimize the separation process, assuring optimum efficiency and lowest waste. The leftover skim milk is frequently recycled into other dairy products, such as low-fat milk or yogurt, demonstrating the factory's commitment to sustainability. At the end of this procedure, the cream is collected in big stainless steel tanks and prepared for pasteurization. To maintain year-round production, manufacturers frequently purchase milk from a network of regional dairy farms, which diversifies supply and mitigates the impact of seasonal changes. Many of these farms take part in sustainability efforts, such as water conservation and renewable energy use, which are consistent with factories' dedication to ecologically responsible operations. The milk is delivered in insulated tankers to keep it fresh, and it is analyzed upon arrival for other characteristics, such as protein content and acidity, which influence the quality of the cream and, eventually, the butter. To ensure safety and consistency, the cream is pasteurized and standardized. Pasteurization is a vital stage in butter production that involves boiling cream to kill dangerous bacteria while retaining its natural taste. Typically, the cream is heated to approximately 85 degrees Celsius, 185 degrees Fahrenheit, for a set period of time before being swiftly cooled. This method not only ensures food safety, but also improves the cream's shelf stability, enabling for more efficient production downstream. During pasteurization, specialists use modern sensors to monitor the cream's temperature and flow rate continuously. These technologies ensure that each batch of cream is heated evenly and meets stringent regulatory requirements. Following pasteurization, the cream is homogenized to achieve a homogeneous fat globule size, which contributes to the butter's smooth texture. The cream's fat content is then standardized, usually at a range of 35 to 40%, depending on the desired properties of the finished butter. This exact calibration assures consistent flavor and texture across all batches. Any excess cream is stored in cooled containers for use in subsequent manufacturing runs, saving waste and increasing efficiency. For enhanced efficiency, several facilities combine pasteurization with high-temperature short-time (HTST) processing. This process rapidly heats the cream to even higher temperatures for a shorter period of time, increasing bacterial removal while keeping the cream's delicate taste profile. During standardization, modern blending devices may combine creams with slightly varied fat contents to reach an exact, uniform proportion, ensuring that every batch of butter meets the same quality and texture criteria. After pasteurization, the cream is cooled and allowed to age to develop its characteristic flavor and texture. to ensure its freshness and optimal consistency, the pasteurized cream is rapidly cooled to roughly 5 degrees Celsius, 41 degrees Fahrenheit, using sophisticated cooling systems. After cooling, the cream is moved to aging tanks, where it rests for 12 to 24 hours. This stage permits the fat crystals to solidify, which is essential for the smooth and creamy texture of butter. Aging also improves the cream's taste by causing modest chemical changes during the resting time. Some companies may add a culture of lactic acid bacteria to the cream before aging it, resulting in a tangy, cultured butter with a distinct flavor. These bacteria contribute to the development of complex flavors, making butter more fragrant and creamy. The aging tanks are outfitted with automatic devices that monitor temperature and agitation, maintaining uniform consistency throughout the cream. Regular sampling at this point allows experts to verify the cream's readiness for the churning process, ensuring it fulfills the factory's high-quality standards. To improve the cream's quality while maturing, some producers utilize specialist tanks with moderate, gentle agitation. This action keeps fat globules from settling and enables even cooling throughout the batch. For artisanal or luxury butter products, the cream may be matured for an extended period of time, allowing it to develop deeper, more complex tastes. During this stage, factories meticulously monitor pH levels to ensure the best conditions for making butter with a rich and creamy consistency. Churning transforms the aged cream into butter by separating the butterfat from the buttermilk. During the churning process, industrial churns agitate the cream at high rates. This mechanical motion causes fat globules to clump together, resulting in solid butter granules. At the same time, the liquid element of the cream, known as buttermilk, separates and drains away. This change is an essential stage in transforming cream into the rich, creamy butter we know. Factories utilize large churns that can process thousands of liters of cream in a single batch. These machines are outfitted with sensors that check the consistency of the butter granules as they form, ensuring that each batch has the desired texture. Some facilities additionally use vacuum-sealed assisted devices to extract any leftover air, resulting in a denser, creamier product. The separated buttermilk is collected and repurposed into other dairy products, such as beverages or baked items, reducing waste. As the churning process nears completion, the butter granules are rinsed with cold water to eliminate any remaining buttermilk, which improves the butter's shelf life and flavor. This technique also gives the butter its distinctive pale yellow color and silky texture. To accommodate different types of butter, such as unsalted, cultured, or European-style variants, producers might change the churning speed, length, or temperature. For example, European-style butter has a higher butterfat percentage and is churned for longer to generate a thicker, creamier texture. Some facilities use microaeration techniques during churning to make lighter butter for specific purposes, like spreads. These precise modifications ensure that each butter variety fulfills its intended usage and consumer expectations. The freshly churned butter is washed and worked to achieve the perfect texture and purity. After churning, the butter is carried to washing stations and thoroughly rinsed in cold water. This process helps to eliminate any remaining buttermilk, which may alter the flavor and shorten the shelf life of the butter. The washing procedure is meticulously managed to assure that no additional moisture is absorbed by the butter, keeping its creamy texture. After washing, the butter is sent to mechanical kneaders, which gently work it to distribute moisture and remove any air pockets uniformly. The kneading process also guarantees that the butter structure is smooth and flexible, making it easier to shape and package. Fine granules of salt are evenly integrated into the salted butter during this stage, which enhances the flavor and acts as a natural preservative. At this point, some manufacturers also make specialty butter, adding substances like herbs, garlic, or honey to create unique flavor variants. Even with these more complex recipes, the kneaders have precision settings to ensure equal blending. Before beginning the molding and packaging process, each batch is evaluated for texture, moisture content, and flavor. In addition to mechanical kneading, some manufacturers employ vacuum technology during the working stage to eliminate any remaining air, resulting in a denser and creamier butter. For gourmet butter variants, extra additives such as spices, honey, or truffle oil are added during this stage and precisely blended to guarantee uniform distribution. Unsalted butter factories take special care to keep moisture levels low, because this variety relies only on purity for flavor and preservation, making the working process even more crucial. Finally, the butter is shaped and packaged, ready to reach consumers. The smooth, worked butter is transported into molding machines, where it is formed into various shapes such as blocks, sticks, and tubs. Factories frequently employ changeable molds to accommodate varying packaging sizes and regional preferences. For example, smaller single-serve pieces may be molded for the food service industry, whilst larger blocks are made for wholesale distribution. Once molded, the butter is mechanically wrapped in packaging such as foil, parchment paper, or plastic tubs. These materials are intended to keep the butter fresh by preventing exposure to air and light, which can destroy its quality. The wrapping technique is precise, resulting in a tight closure that preserves the butter's flavor and texture. After wrapping, each item is labeled with important information, such as manufacturing dates, batch numbers, and nutritional information. Advanced printing methods enable firms to add QR codes on labels, allowing customers to track the product's origin and learn about the manufacturing process. The final packages are meticulously inspected before being bundled and shipped to cold storage for distribution centers. To improve sustainability, several firms are switching to environmentally friendly packaging materials like biodegradable parchment paper or recyclable foil. Some brands also employ resealable tubs or unique vacuum-sealed bags to increase the butter's shelf life and reduce waste. Advanced automation ensures that even the most delicate specialty packaging, such as hand-wrapped artisanal butters, remain precise and consistent. Each package is intended not just to protect the butter, but also to improve its visual attractiveness, demonstrating premium quality to customers. Once packaged, the butter is stored and distributed to ensure it arrives fresh and ready for use. The packed butter is kept in cold storage chambers at specified temperatures, often between 2 degrees Celsius and 5 degrees Celsius, 36 degrees Fahrenheit to 41 degrees Fahrenheit. This guarantees that the butter preserves its texture and freshness until it is ready to ship. High-capacity refrigeration systems include real-time monitoring to track temperature and humidity levels, ensuring the butter's quality during storage. To keep the butter refrigerated throughout transportation, it is placed inside insulated boxes or crates. Refrigerated trucks are utilized for deliveries to grocery shops, restaurants, and wholesalers. These vehicles are outfitted with innovative tracking systems that monitor temperature and location, ensuring the cold chain remains intact during travel. Factories frequently work with logistics partners to optimize delivery routes, decreasing travel time and the carbon footprint of transportation. Butter is shipped internationally in refrigerated containers, allowing it to reach worldwide markets while maintaining high-quality requirements. When the butter arrives, it is stored in store refrigerators or transported directly to food service industries, ready for people to enjoy. To ensure consistent quality during storage, firms utilize automated inventory systems to monitor stock levels and organize batches based on production dates, ensuring first in, first out (FIFO) procedures. Butter is frequently exported to international markets on vacuum-sealed pallets with refrigerated containers, which helps to keep it fresh over long distances. Some manufacturers collaborate with green logistics suppliers to reduce the carbon footprint of shipping, complying with environmental goals while delivering the same high-quality butter to consumers worldwide. From fresh milk to golden blocks of creamy perfection, the butter-making process is a blend of tradition, innovation, and care. The next time you spread butter on toast or cook it with your favorite recipe, remember the incredible journey from farm to table that ensures its rich flavor and quality. Thank you for accompanying us on our excursion to see how butter is created in a factory. Don't forget to like, subscribe, and click the bell for more unique insights into your favorite meals. See you next time.